Final thing you need to worry about is just calculating for engineering the value of resistance if there's more than one resistance to flow in a line. Comes two ways. It either comes in series, where there are one after the other, in which case you just add them up. So resistance total equals resistance 1 plus resistance 2 plus resistance 3 plus, and off it goes. Or they might be parallel. If you think about this like water flow, if I've got a river that splits into two, then the total resistance is lower. Yeah? Here, if I've got water flowing along, the resistance is higher. Yeah? The formula here is 1 on resistance equals 1 on resistance 1 plus 1 on resistance 2 plus, and then if you've got 3, 4, 5, however many. This is something you could easily expect in the HSC. Calculate the resistance of this. How do you do it? That's that right hand side there is parallel. So you calculate that one first, then you've just got one resistance plus a second resistance and you add them up as though they're in series. Make sense?
Yeah.
Okay, so let's just do that to calculate the resistance of this one. 1 on resistance equals 1 on 60 plus 5, 1 on 5 equals 1 on 60 plus, if you can go with me on this, 12 on 60 equals 13 on 60. Therefore the resistance equals, invert that, 60 divided by 13, and the answer will be whatever that works out to be. Could somebody with a calculator, if anybody's got one, figure that out?
4.62.
4.62 ohms. So it's less than the 5 because that 60 is actually giving some of the electricity another path to go through. Make sense?
Yeah.
So now we just go, this 15. This is the Australian standard symbol for resistors, by the way, just a rectangle. You'll see in some books they're drawn like this. It's standard in other countries, but in Australia they're just a rectangle. Yeah? So that's 4.62 ohms. Over here there was 15. Therefore the total resistance is 15 plus 4.62 is 19.62 ohms. That's how to calculate value of resistors in parallel and in series.